Welcome everyone for the last talk of the day. I welcome you, Loprivs, that's going to present the ABCs of cloud hacking. And right after at 5:30, we got the CTF that is starting for the registration. So if you want to register to the board, the scoreboards, there's the beginner and the classic one. And again, go on Slack for anything related for a CTF. If you got question, Lopriv, just put it in the chat of YouTube. So thanks again, and you can go on it. You can go.
All right, cool. Thank you, Patrick. So hi, I'm Loprivs, aka Jeff, and we'll talk about the ABCs of cloud hacking. This is an opinionated talk that doesn't reflect my employer, where I discuss certain concepts and things that I feel that when you get into this buzzwordy field, you may find beneficial for you. So if you have comments, questions, feel differently about what I stated, this is a discussion, right? So you please feel free to voice your opinions. So like Patrick stated, I'm Loprivs, I'm Jeff Heyman. I'm a security consultant at Security Compass, and I enjoy participating in Hackfest. And before I start, just quick interrupt, Black Lives Matter, period. And that doesn't mean gimmicky apologies and things like that. It really means just making sure that we continue to reach out and knowledge share with community, underrepresented communities in tech. So that's the Black community, POCs, LGBTQ community, women in technology, things like that. So those are a few resources I found helpful. Obviously, there's more. So just stay in mind for that and continue to kind of stay awesome in the sense of growing this community and reaching out to further groups. We can only get better with that. Now, for an overview, we're going to go over what does it mean to perform cloud hacking, air quotes, or hacking the cloud, or manipulating the troposphere. So how do we actually reference that line of work? You can't really put on your resume cloud hacker, or you can, no one's going to judge you. We'll also go over the skill sets and possible mindsets that should be beneficial. This is kind of where do you begin with this? What tools should you have in your repertoire, things like that. And what can we take away from popular media and case studies in how cloud technology evolves and addresses security issues? So to first understand what it means to be a cloud hacker, you should probably understand the concept of cloud, or whatever someone tells you they're talking about cloud. Microsoft had a good quote, so I'm using that. Simply put, cloud computing is the delivery of computing services, including servers, storage, databases, networking, software, analytics, and intelligence over the internet. So to sum that up, if you use a service over the internet and you're not sure how it works, it's probably a cloud service. And when we talk about cloud services, one thing that's been popularized is the shared responsibility model. Essentially, you use a service and the vendor acknowledges or promises to, through their software license agreement, to cover these aspects of the service infrastructure. So traditionally, when you're on premise, you manage your own servers, you do everything from ground up, network connectivity, physical security, things like that. When you use something like infrastructure as code or infrastructure as a service, the cloud service provider states that up to the virtualization standpoint, we got you covered, and you manage the type of operating system you put on the stack, any type of middleware, how it handles in runtime, the data, the application configuration, and so on and so forth. And this moves up as you go to platform as a service and software as a service. One interesting aspect about software as a service, even though that's fully covered, and you can have the blind assumption that, yep, you don't need to do any work, you still need to address issues with software as a service, namely around authorization and authentication. And potentially, depending on the product, how the data is stored and where the data is stored in the software. So to make it a bit more familiar or recognizable, these are some of the popular products that are in that cloud environment. One thing to note is when it comes to the bigger players in the field, Amazon, Google, Microsoft, they're usually in all layers of that stack. So we'll start as infrastructure as a service, storage as a service. So that's kind of like your Dropbox, OneDrive, and things like that. Platforms as a service, still AWS, Azure. If you dig deeper into like Google services, that'd be App Engine. You have databases as a service. Oracle comes to mind. Any of the products inside of the cloud service provider also would be data as a service. You have function as a service, used to be known as serverless. This is a bit more accurate, where you have functional runtime capabilities that handle all the server deployments, and you just focus on the connectivity and the functions or applications that are that run on top of it. And then you have software as a service, which is pretty familiar for most people. That'd be your Slack, your Office 365, Salesforce, et cetera, et cetera. Essentially, if you have barely any control of that service, it's probably a SaaS. So, are we cloud hacking yet? The way I see to kind of break that down, when someone says I'm a quote unquote cloud hacker, or I do cloud pen testing, or I exploit cloud vulnerabilities, or insert any other clickbaity title, you're really looking at, are you identifying security misconfigurations of cloud-based deployments? That would be someone has taken the puzzle pieces offered to them by the cloud provider, and they've kind of fit it in a way that it works, but there's still some gaps, and that's what you're looking for. That's namely an organization purchasing cloud services and then deploying and then building on top of that. So you find that in more traditional penetration testing against the vendor using the product. And the primary concern is not really to find ODAs inside of the cloud vendor specifically. You can, it does happen, but namely just to ensure that the company that you are performing the work for has implemented things correctly and safely. Then you have finding vulnerabilities in underlying cloud technology. That is when you're actually looking for those misconfigurations that the cloud, or the security vulnerabilities that the cloud provider has presented to customers and clients. So that may be an internal team inside of the cloud provider or the SaaS vendor. This may also be researchers and bug bounty hunters. And this is when they're kind of taking apart the niceties of those data plane APIs and really trying to see how things tick, how things work. And then you have kind of injecting, orchestrating, taking control of the cloud environment and bending it to your will. And that's when you're building on top of the cloud service as potentially a security engineer or internal security team to ensure that your security controls are reflected in your cloud environment. Am I cloud hacking yet? So when we look at finding issues in implementations or security configurations, this is represented popularly in your post-exploitation exercises. You've compromised an asset or a resource or found a vulnerability in the vendor's application, and you find out that they reside in the cloud infrastructure. How do you navigate that? How do you really demonstrate that, yes, this was a problem that you had? Okay, I see that the screen size is too small. Let me try to adjust it. Let me know if that's better. Yep, so you have, let's see if I can adjust it more. Just gonna stop for a sec. Hey, Patrick, is the screen size okay on your end?
Yeah, much better. Thanks.
Okay, cool. So continuing on. So now when you look at the post-exploitation side of the cloud infrastructure, you're trying to see how you can demonstrate gaining access to important data stored in the cloud environment, or pivoting to additional services and networks that may reach to on-premise for that organization. Also, when you consider the security configuration aspect of things, you are also looking at, is the resource on its own configured correctly? For example, S3 bucket, S3 storage. Are all the check marks enabled? Should they all be enabled? What's the context inside of that? And is the resource securely configured when it talks to another service or resource? For example, is encryption in transit satisfied when one cloud's product talks to another? So, tell you more. When we think post-exploitation exercises, we are looking at how best we can pivot and how we can interact with data storages, and additionally, how we can stay silent on the data plane. So one example would be when you initially gain access keys or security tokens that can talk to the cloud service endpoint, you may want to discover what privileges you can perform. One popular tool is Weird Al, which essentially brute forces all your potential capabilities. Well, just keep in mind that for a lot of mature companies, all that's being logged, for example, in S3 through CloudTrail. So what they're going to get is a lot of noise, a lot of access denied when you perform that action. So sometimes you have to think a bit deeper on the context of your access keys in your data, or how that key is supposed to work. And I would be remiss if I didn't acknowledge a lot of people in the field for this. So you have Dirk Jan, who is a very strong researcher and has been focusing on the Azure landscape of things. So he essentially looks at the trust relationships inside of Azure and has identified a few issues, how to navigate, how to enumerate. Very good person to follow on Twitter. You have Pyrotech, aka Sean Metcalf, who has been for quite a few years a good staple for Active Directory knowledge, which bleeds into Azure Active Directory, and just a good reference point to build off of. Another one is initstring, which is Chris Moberly at GitLab currently, and he's done a bit of research around the Google Cloud space for privilege escalation and just understanding the cloud metadata service over there. And then you have Scott Piper, who's done research in the AWS side of things and is notably known for his open source tool, CloudMapper. Now, when we look at security misconfigurations, you have a short checklist of, is it configured correctly by itself? Have best practices been enabled? Does it make sense to enable all those best practices? And can you defend your reason why? So for example, access logging for S3 buckets. Essentially, you enable that feature, you can have a log of who sent HTTP requests to your cloud storage service. That is great for any cloud storage service or S3 bucket that you deem critical or important or public facing. But to enable that, you are then creating another bucket to log those requests on. So does that mean you need to then enable logging on your logging bucket? Maybe, but you're going to get a bit of recursion there. And that wouldn't be the best idea, right? I have seen a wonky design. Maybe I implemented myself by accident where I had my logging stored on the same bucket I wanted logs for, which just made infinite amount of logs because it's just logging itself, making those logs. So context matters, and knowing how best to address, configure, and fight those battles for what should be enabled and secured correctly. And additionally, you're gonna have a responsibility, especially internally inside the organization, to take your architecture diagrams and ensure that they are deployed correctly and reflect the security and threat model that you may have worked on during the earlier stages of the design process. So what does that entail? Well, you're not only dealing with cloud services alone, you are dealing with whatever is built on top of them. So this is just the landscape of cloud native technology by the Cloud Native Foundation, which is essentially any type of framework or tooling that can be built and deployed inside cloud environments, namely on top of containers with alongside Kubernetes for orchestration. That's a lot of services, and you may need to become familiar with them depending on your on the stack that your organization uses. And it doesn't stop there. As you evolve, you need to get familiar with the evolving services of the specific cloud service provider. So this is AWS's list of services that they offer currently. It runs about 160 plus services, and it ranges from compute, storage, databases, migration, network, developer tools, blockchain, satellites, quantum, governance, media, machine learning, analytics, security, mobile, augmented reality, virtual reality, application integration, AWS cost management, end user workspaces, Internet of Things, game development, and of course, containers. So there's a lot of landscape there, and potential security misconfigurations and potential security research is plentiful. So some references that I would recommend is always start with the cloud service provider directly. They usually have documentation, training, certification programs. You need to be familiar with that at the start, just to know what you're talking about and know how to address complex problems and design questions. So each of the providers have something, from Microsoft to Google. Now, thinking about compliance, and that sits in that kind of security misconfiguration, you still got to do it. And one thing that I've seen is the assumption that because a cloud service provider advertises their service as HIPAA compliant, that does not mean you're inherently HIPAA compliant for just using it. You still have to configure it in a way that satisfies your HIPAA or other regulatory requirements. And that's something you'll have to check for when you're doing your security misconfigurations. Again, additional references, always start at the cloud service provider. Another one that I would strongly recommend is the Cloud Security Alliance. They've done a great job of mapping the current controls that you're familiar with to cloud requirements and cloud resources. So now we look a bit deeper at what I would say is truer statement of cloud hacking, because you're actually attacking or looking for vulnerabilities in that service. So one of the case studies that I found interesting, and it came out pretty recently, I would say later half of May this year, is work done by Ezequiel Pereira, and I've butchered that name and I apologize. They did work for Google to obtain quote unquote remote code execution from the Google Cloud Deployment Manager. Google Cloud Deployment Manager is essentially, if you want to reference it to anything else, it'd be similar to CloudFormation or Azure Research Templates, which essentially is remote code execution as a service where you can automate your deployment of additional resources in the platform. And what they were able to do was leverage Google's SLB, their service load balancer, to make requests internally to other APIs that acknowledged that service. So this potentially allowed for privilege escalation, interacting with data that they may not own, and Google acknowledged it, gave him about like a $30,000 bug bounty, and he was able to write up on it. So definitely check out his blog. The key takeaway there is his process. they acknowledged that this was a slow process. And for vulnerability research inside of cloud services, there's not a lot of bug bounties or CVEs dropped. So it is a slow process. They do a lot of work internally before they release things out. So I would guess it probably took them months or weeks to get a research and find a bug. Another thing is the work process where they proxied requests. They really read up on the API documentation and looked into SDKs, which is usually the things that are available to you always as a customer or outside user of the cloud service provider. So it's best to really work on top of those. So now, from more of a security engineer role, you have quite a few responsibilities when you're in a cloud related infrastructure. You need to centralize your data, and some of your data is asset management, which is a very easy problem to solve, I say sarcastically. And you need to have a strategy around that for cloud deployments, shadow IT, things like that. You then need a way to identify what are security relevant logs for you and how to pipe that into your centralized dashboard or SIEM, while also considering cost, especially during this dystopian future where we have a pandemic and other issues. Cost probably is now a key factor for every team in the organization, including security. So again, I've linked to the relevant URLs for the cloud service providers that have comments or recommendations. And I've also included the MITRE ATT&CK framework, where you can gain and model some TTPs related to cloud enterprise. In addition, Netflix has been a pretty strong or pretty vocal company inside the AWS side of things, and they've dropped quite a bit of tooling that security teams can apply. And some of the tooling is still relevant. Some of it is not, because the cloud constantly changes, and usually the cloud service providers attempt to add in those services natively in the platform, but definitely worth looking at. So what skills should you have for this? And so I've coined about 3 concepts that you can build on top of. You need to adapt and deep dive, which means you need to be able to study and learn new technology, and you need to know it from a non-superficial point of view, which means you can understand the nuances of it, and you can tell someone that, yeah, the way you want to do this implementation is not the way you think it will work. And to have that kind of knowledge, you need to build your labs. You need to really put your money where your mouth is. So each cloud service provider has like a $200 or a yearly free trial. And that's when you can really just work with the APIs, deploy them, see how they work, see how they're presented, see the time it takes for them to get deployed, and how to build on top of that, and how to log for those actions. And then you also need to stay up to date with information. So make sure you collect data feeds and stay informed. So that's RSS feeds for the cloud service providers, the blogs, and any research from people involved in that field, usually through Twitter. So when we say adapt and deep dive, that does mean knowing how the API and SDKs work. You should also align it with whatever programming language that you're familiar with, if you are familiar with one, because in most cases, tooling will break, or you will still need to fix things and work directly with the API. For example, Cloud Mapper, great tooling, but does not work on Windows environments, namely because there is a library on the Python stack that does not compile inside of Windows environments. I think it's PyJQ. So you need to adapt and be able to add some programmability into that environment. Yeah, I'll drop the links in chat when I can. So these are some resources. I would say start from the cloud service provider, look at their SDKs. They're usually pretty good at explaining them. And once you do that, you can start setting up proxies and seeing if what they say the APIs do, you can verify it. When it comes to building your lab, I strongly suggest infrastructure as code, whatever that means to you. I personally use Terraform quite a bit, but you can also use the native cloud service providers, CloudFormation, Azure Resource Templates, and Google Deployment Manager. Why I recommend doing this for your lab environments is you don't want to pay later because you forgot to turn off a service. And usually infrastructure as code allows you to destroy whatever you've built pretty effectively. And when it comes to kind of learning things, start from the GUI or graphical user interface just to see how what the end process is. Then look at the SDK and work with that. And then start proxying the request through Burp Suite or whatever proxy tool you fancy, just to see really how requests are being sent and how the protocol works. And these are some additional resources to the tooling I just mentioned. And when you want to collect data and stay informed, all the cloud service providers have blogs that talk about their new resources that they're launching, whether they're in general availability or still in preview mode. And conferences are starting to come out. And as this continues to be a buzzworthy topic, you're going to get a lot more traction from researchers from all sides of the industry. So I linked to that. One of the things you can look forward to is Forward CloudSec, which is a security conference that's focused on cloud technology and topics. So something to look forward to. And what can we take away from information that we see in public reports and vulnerability disclosures and data breaches? Well, data breaches are still happening in cloud infrastructure. Open S3 buckets, open Elasticsearch databases, compromising third-party cloud providers, things like that. And some of the common tropes or attack vectors are becoming harder to exploit. And I'll talk about that in a bit. And this technology stack will get more complex. Think cloud resources think containers inside of Kubernetes that sit on top of your cloud resources and things like that. It's just going to continue to stack and be a bit more integrated and a bit more complex. But you should always stay positive and excited about the technology, or you may have to deal with depression. So just try to stay positive on that. So, for example, one of the popular things that came out last year was Capital One's data breach, which a lot of people surmised it was around server-side request forgery to the metadata service. So one thing you can note is AWS has introduced their version 2 of the metadata service, which is now a session and requires headers to make the requests to. Azure's always had header enforcement, plus they drop X forwarded for headers, which is usually what is sent to the endpoint if you're performing a server-side request forgery attack, a traditional one. And Google has the same concept. So this is an example of how things have evolved from popular attack vectors to now making it harder, a bit more difficult to work with. Of course, unless if you downgrade the request. So depending on how you configure your metadata service, you may still have the legacy support where an attacker can use their traditional server-side request forgery attacks. So that is an example of the cloud service provider has done some of the work, but you need to kind of close all the loopholes and make sure that a legacy attack can't be performed. Another one is domain hijacking. So I think it was 2018, it was pretty popularized where you could just sit on a domain name that was abandoned or a cloud resource that was abandoned that tied to a domain name and profit. So one thing I've noted after a failed demonstration is AWS has changed some of that logic where if you were to create an S3 bucket then destroy that S3 bucket, another account that knew the name of that bucket, and maybe they knew it was tied to your internal to your DNS registry, they actually can't make that resource for more than 4 hours, giving you enough time to say, oh, I made a mistake, I should really clean up my DNS, or I should redeploy my S3 bucket or whatever domain name related resource. And that's the talk. So yeah, thank you for taking the time to listen. Are there any questions, concerns, comments? And just keep in mind, it's a lot of services, but don't feel overwhelmed, and just kind of stay the path.
Hey, thanks a lot, Jeff. There's not really a question, but people will be interested to get all the URLs in your talk. So if you can post them on the YouTube, and I'll add them to the YouTube description, that'll be awesome. But I think it covers the question for now. Thanks again for your time. That's awesome. CTF registration are started, so you